Let's do a little bit of programming. Okay. So really, the next thing to do is like try and actually just finish off the parsing. So we have win conditions next, which should be fine. Okay, win conditions. Although I still haven't done a couple of things for rules, but that's fine. Win conditions. Cool. Let's just begin doing that. So parser needs a couple of things. It's going to need a thing here. I guess it's already got a thing here. New win conditions. And that does this. So I guess win conditions contains conditions, which will be a vec. And then where is that defined here? Win condition node. Yeah, win condition node, cool. Then we just need to have the win condition node. So mod win conditions, not mode, mod pub use win conditions. Yep, indeed, not found. We're going to make it. Win conditions. So win conditions is going to look a little bit like, oh, okay, I've made a mistake. Here it should be win conditions node, because we're not doing an individual win condition. Yeah, I've messed this up entirely. It should be, okay, win conditions node is going to have conditions. Win conditions node, not found the scope, correct. So I'm going to do this. Win conditions node is going to have conditions, which is going to be a list node of win condition node. We do need that. We don't need that currently. We do need list node. Source span we don't need right now, and we don't need you. Okay. Okay. And then so we're just going to define the structure. Win condition node. Okay. I think this is actually going to be an enum. I think. Let's have a look at what a win condition looks like. Parser script. First steps, documentation, bird's eye view, win conditions. So these are the valid formats. So we have, what should we break it into? We have, so they either begin with no, all, or some. Alternatively, we can break it up by whether they're like on things. Now, it would be nice if like all target existed, but it doesn't. Because then we could just say, well, it's either a no whatever, an all something, or a some something, and then the on is always optional, but that's not the case. So yeah, I think what we want to do is based on, like, we want two types, right? We want an on. There's like the global ones and the local ones. Like a local win condition is one where all targets on crate. Well, if every target point has a crate on it, all targets on crate. Is that what that means? Yes, for every target there is a crate there, yes. For some of the things there is a thing there, yep. Yes. Okay. For none of the thing... Oh gosh. For all targets there is a crate there. For all gold... there is some gold on chest. No gold on chest. I'm just trying to generalize this logic. All targets on crates. It's not really local. It's like on, yeah. Constrained. It's like there are two possibilities for a win condition though. They're either like, yeah, global or local. Local's a bad name for it though. But what would they call it otherwise? Like, well, on versus... Now, one of the problems we're going to have here is that we don't know whether it's an on or not until we've got to there. But that's okay, I guess. That's okay. That makes this the node, which it is. That is the node. And we know it's going to be an on node or a non-on node. Just need a good name. What is a good name for this thing? I guess like unconstrained and constrained. Let's just keep going with that. So we're going to have an unconstrained condition node. Or unconstrained win condition node. Oh yeah, there was another thing I wanted to do with my my derive macro, but we'll do that later, I guess. Win condition, no. This. An unconstrained win condition node has. Well, no, I think I should do this differently. I should do it as this. No, I can't do it as this. Just a, yeah, okay. Because one of them allows all and the other one doesn't. Are these even like mathematically equivalent? Like no fruit and no gold on chest. There are no fruit left. This is like looking at all the cells that have chests and then applying that to it. It's like constraining the set of cells you're checking. Is that the same? It's the same true here. You went for some gold, well, some gold on chest. So some gold by itself would mean just there is some gold somewhere. But specifically saying there is some gold in cells that have chests. Yes, okay. So they are semantically equivalent. So all yeah, so if you said all, I mean, we could just allow it. Like, it's funny that all fruit doesn't exist. I guess what it would mean is all, every cell has fruit in it, and then on crate, all fruit on crate would mean that specifically looking at, is that what that means? I need to even double check. I feel like they're badly named. Let's just load the basic example and do, okay. So that it's all target on crate. All target on crate, yes. So if we do some target, let's just move, let's do this, not that, this and this. Do some target, no, what are we doing? Some target on crate. That just means that will win, yes, okay, of course. And what is the reason, like, there's a reason we don't do like all crate on target. The reason for that is, I mean, I think it'll work fine here, right? Well, the problem would be is if there was like an extra crate like in the corner, this wouldn't be satisfied, or would it? Okay, I can't put it there. I can't just put a crate there. I can put the crate there. There we go. All crate on target. Well, they're not all on target, but all target on crate. Right, okay, so the better way of thinking of this is not that... Yeah, Let me just check, so this way round. Yeah. So that is actually more like what I was thinking. This win condition basically says... everywhere there is a target, there must be a crate. Uh-huh. And here it says, in some of the places there is a target, there must be a crate. Mm-hmm. Some of the places there is a target, there must be a crate. That effectively means. Uh-huh. Which is equivalent saying some of the places there is a crate, there must be a target. But it's better to think of it as all the places, some of the places there is a target, there must be a crate, because this is all the places there is a target, there must be a crate. Yes. So, the problem is that some target, for example, just means that there must be some target in the thing. All the places there is a target, there must be a thing. Yeah, okay. These are not really equivalent to each other, are they? let me write them all out. So we've got some target on crate. Some of these won't make sense. No target on crate. Then we've got some target and no target. These are all the possibilities. And what they mean is everywhere there is a target, there must be a crate. Somewhere there is a target, there must be a crate. Nowhere there is a target. Nowhere there is a target, there must be a crate. Sure, that is not a bad way of wording it. Okay, and that makes it consistent between all of them. But this means somewhere there must be a crate. So the problem is, sorry, a target, is that the equivalent object in these things is actually the bit after the on with the thing that's after the sum here. Which is kind of weird. What would be a nicer way, if I were designing this from scratch, how would I do it? Nowhere there must be a target. Nowhere there is a target. No, that's not even right. What's that even mean? Nowhere there is a target, there must be a crate. Nowhere. No, that's right. So, any place that has a target. Nowhere there is a what a weird sentence I've written. Nowhere there is a target. Yeah, I mean, it kind of does mean what I want it to mean. I mean, I guess the equivalent would be everywhere there is a target, there must not be a crate. Everywhere there is a target, there must not be a crate. So if I did do a thing like if I did do no target on crate, win condition happens immediately. No target on crate. If I put U on U, this won't win. Everywhere there is a target, there must not be a crate. Then it will. Okay. And then what happens if I have no targets? Nowhere there is a target, there must not be a crate. I feel like this will win then. Immediately. Yes, okay. But it won't do the same if we have just targets. It will, okay. Oh, well, it's because we don't have just targets, we have a crate there. No, that still wins, okay. Everywhere there is a target, there must not be a crate. Yes, okay. Everywhere there is a target, there must not be a crate. Right. Is that equivalent to my phrasing, nowhere there is a target, there must be a crate? Nowhere there is a target, there must be a crate. That's awful grammar. Nowhere there is a target, there must be a crate. Yes, that is equivalent. Okay. Some target I guess what I'm trying to get to is that is basically some target equivalent to some target on anything, if anything were, or like on backgrounds. assuming background couldn't be removed, which it can, but yeah, that's on anything. It is equivalent to that, right? No. No, it's equivalent to... Maybe it is. Maybe it is equivalent to that. Some target on anything. So if there were no targets, it would fail. Same as if there were no targets, there's some target on crates. Yes. And if there were no anything, if there were no cells, then it would also fail. Some target on... If there were no crates, then that would also fail. So yeah, it's equivalent to that, right? So then, is it not absolutely reasonable to have a new thing called just all target on anything? What would that mean? It would mean anywhere, wait, ooh, everywhere there must be a target. Is that right? Somewhere there must be a target. Nowhere there must be a target. And this, to be equivalent, would be everywhere. Somewhere. No, once again, it is like the second bit here, isn't it? Is it? Oh, have I got that wrong? Okay, so something I need to quickly understand is, if I say some target on crate is this A, oh, I can't do that. Everywhere there is a target, there must be a crate. No, somewhere there is a target. Or is it B? Somewhere there is a crate, there must be a target. Is there a difference between those? Oh gosh. Somewhere there is a target, there must be a crate. Somewhere there's a crate, there must be a target. Those seem equivalent to me. So then I think the better one to ask it for is all. Is this everywhere there is a target? Or everywhere there's a crate? Are these equivalent? Everywhere there is a target, there must be a crate. So no, this is not equivalent. And this is easy to test, right? So this is... Everywhere there is a target, there must be a crate. So all target on crate. That is saying that all targets must be on crates, but there may be extra crates. So it's the first one. Everywhere there is a target, there must be a crate. Which is what I wrote down here. Right, and that's what I was testing with this, when I did this. Because the thing is, all target on crate, there can be extra crates. Yep. So it's A. Everywhere there's a target, there must be a crate. Right, okay, so the question is, can you rephrase the... So we can also think of some target on crate as being somewhere there is a target, there must be a crate, I believe. That should be equivalent. Somewhere there is a target, there must be a crate. Yes, I think that's right. And then we've got no target on crate. Let's just double check that that works the same way. This is the weirdly phrased one. Nowhere there is a target, there must be a crate. Yes, that's perfect. So they all match up with each other. So then, oh gosh, nowhere. So some target. Could we phrase that as somewhere there must be a crate, or somewhere there is anything, there must be a crate. So it's basically the same as on anything. Somewhere there is anything, there must be a crate. Yeah, that. Oh, sorry, must be a target. So this is the thing that bothers me. No, that isn't equivalent. Somewhere there is a target, there must be anything. Does that work? Maybe that works. Somewhere there is a target, there must be anything. Sure. Because that will only apply if there's a target somewhere. And there can be anything. And there can be extra anything. But there must be a target, because there's somewhere there is a target, there must be anything. Okay, so does that work for no? So nowhere there is a target, there must be anything. Nowhere there is a target. What does that mean? Nowhere there is a target, there must be anything. Yes, okay, that is fine, because that will mean that there is no target anywhere. Okay, cool. So then what will... It doesn't exist in puzzle script, but what would on target, all target on whatever, it would mean, so if we use the same structure, everywhere there is a target, there must be anything. Everywhere there is a target, there must be anything. I mean, that would just like, if there are targets, that will be exactly equivalent to that, right? Because there's always going to be anything. Yeah, okay. That's why it doesn't exist in puzzle scripts. Everywhere there is a target, there must be anything. Because anything, it means like, literally, like, also nothing, just like a cell. There is a cell here. Everywhere there's a target, there must be. So yeah, those two end up being equivalent. Now the question is, should I model it so this is allowed? Because the thing I'm trying to decide is like, should I model this as like, should I group these as a kind of node, and these as a kind of node? Or should I put the sums together, the alls together, and the nodes together? But that only, so that second option only makes sense if I'm going to allow all, which is a kind of pointless thing to have. So maybe we just follow puzzle scripts approach. I might actually, I'm going to bring this across because it's worth having as a note in the source file. Should we do this? This, nowhere there is a target, there must be anything. Oh, wait. Yes, okay. So all target, which does not exist, but that would be everywhere there is a target, there must be anything. And yeah, that would end up being exactly equivalent to that. Okay. Okay, so we're going to say that that's not allowed. Equivalent to some, so doesn't exist. Nowhere there is a target, there must be anything. That's such a terrible sentence, but I love it. Nowhere there is a target, there must be anything. Okay. So the question then comes back to, like, what do we call these? Somewhere there's a target, there must be anything. Being unconstrained and constrained could still work. Sure, let's just keep calling it that. So an unconstrained win condition node is going to be what should we call this? All, some, no. Well, no, just some and no. Unconstrained selector. Oh, selector. And that's going to be an enum, but just a normal enum, not a AST node. And this will be some or no. And then we have the constrained selectors, which will be all, some, and no. But these are going to be, let's open up, let's do that. Let's open up this. We are going to do this. Oh yeah, so I've made a mistake. I've made a mistake. This is going to be keyword node. Where it's that and unconstrained selector. And then we're going to have object name, object ref is going to be an optional I won't put the option in yet, so object ref will be an identifier node. Source. Then that's that. Okay, and then the constrained node will be constrained selector on on. This will just be a static stir. Static stir. What do we call the thing it's on? The constraint. Constraining or constraints object ref. Which is going to be an identifier node. Does this compile? Probably not. Maybe if I import the stuff I need. So we've got keyword node, identifier node, that's everything. Huh, it compiles. Okay. Okay. So then we need somewhere where we can start to actually parse this stuff. So right now we've got this, and here we don't have a section for win conditions. Win conditions section. Some win condition. Parse win condition. Win condition section. Conditions. Yeah. Push. Win condition. Yep, that's correct. There is no parse win condition function. But there will be. So there's going to potentially be an issue here. Because it's the first time I've had a thing where the node doesn't depend immediately on the keyword at the beginning of it. I think it's the first time. Yeah, like everything else I've been able to tell what a thing is just by what the first token that I pass. Here I don't. But that's fine. Let's copy collision layers or something. Now what's the most similar thing? Legend. What is the most similar thing to what I'm doing here? I guess like sounds is actually the most similar. Parse one of. Interesting. I might start off simple. Let's copy this. Which is not the simple thing to start with. But where are we? Win conditions. Okay. Let's get rid of all this. And that. Let's just start with this. In fact, we might just go even further. Yeah, sure. Parse win condition. Hello. Hello. You made it. Welcome. Did you catch it? Because I never know, like, does YouTube notify people or whatever? What am I doing coding so late? Good question. Well, I didn't do any earlier in the day, so I felt like I should get a little bit of coding in. Yeah, I played far too much Animal Well. Amicable Animal Well earlier today. And then I went to a pub quiz, in which we came fourth out of like 9, maybe, which is okay. Oh no. Well, hopefully, Amicable Animal gets well. I liked your little thing to avoid pixel hunting. That's a very unique way of doing it. And anything we can do to avoid pixel hunting is a win, as far as I'm concerned. And I guess it's nice because it's like opt in when you want it, so you can still have. I guess you still want the feeling of like having to explore the scene and find out what's interactive, but you don't want people to get stuck because there's something they can click on they just haven't realized. Is that thinking correct? I deleted too much from this, didn't I? I totally did. Okay. Parser, but this isn't going to be a thing, it's going to be a win condition. Right, okay, I see. I forgot that you've got the rule of everything has to be diegetic. Yes, real life does not give you hotspots. Although it'd be handy if it did. Would it? What would it even mean? Everything's interactive in real life. Everything would be a hotspot. Was that no to it being useful in real life? Yeah, I think it wouldn't be useful in real life. Okay, so how's this going to work? It is a bit too late for me to be doing coding. I don't want everything to have a glowing outline. But the problem with like real life is that everything is interactive down to the individual particles in a sense. Like if you wanted to, you could. Like a wall in a video game probably wouldn't be highlighted because you can't interact with the wall. But in real life, you could like smash through it. But you could also smash through part of it and not another part of it, and so on. And so basically everything would just be glowing with outline. Each individual atom. Oh, it's too late for me to do this. What do I need to do? Oh, this is not relevant. That's for sounds. So a win condition looks like this. So I need to kind of start passing the initial thing. Okay, I can do some of that. So so there's going to be a parse one of keywords. This is Rust. All of my RS files are Rust. This here is a puzzle script file, which I'm running my Rust parser on. And it's got, I mean, it's a puzzle script file, but I've thrown lots of horrific things into it that are, some things are just not valid puzzle scripts. And some things are valid puzzle scripts, like these spaces here, but nobody would ever really do. Like that's not valid. Asfasf there. It would have to be either the word and or. Well, because that's or, it would have to be or. But I've put gibberish in just to check the errors come out correctly. So that if I do, I can't run it right now because it's not in a working state. I could put it in a working state though. I could just do what could I do? I could do I think that might now be in a working state. Where's my, there we go. It's not. Parser rs, AST rs. Ah, yes, that's correct. Yeah, it's a list node of items. Oh, items is a vec. And then the other error was parser win condition. Oh. Did I not literally just make that? Oh, I have not added it. Parser. HI. Okay. I mean, it probably will rearrange it for me anyway. Oh, no, it's still not there. Right. Oh, yes, that's right. Location nodes. Okay. Well, you're debugging it in a different language and it's all wrong. As in, you're looking at it, applying other language, like the things that you would apply to other languages and going, what on earth is all this? It's all errors. Oh no, I got an infinite loop. I know why I got an infinite loop. I mean, I could just do parser skip until next line, sure. I think that will mean I'm out of the infinite loop. Yes, okay. So, I'm in the middle of writing this bit, but I'm currently writing the bit that passes the PuzzleScript code and outputs an AST. And so this thing here is my AST for PuzzleScript. It's like it's a tree structure where it's indented if it's a child, etc. So if we look at my PuzzleScript file, you'll see this bit gets ignored because that's a comment up at the top. It's a very nonsense looking comment, but it is one. Then you'll see identifier, title, text, the title as stas, which is that bit. And it doesn't take the stuff afterwards because that's not how PuzzleScript works. That's a comment that ends the line basically. And then that is actually invalid, and so there should be an error because it also does error reporting on what it's passing. So there's a thing here saying unexpected code after a prelude option. Something here, foo, error. So I have a nice error reporting thing where I can say like, oh, the error is specific to this thing that I just passed, and it will highlight the particular words. And so there's like loads of errors in the PuzzleScript code at the moment. So these are not errors in my Rust code. These are errors that my code is reporting about the PuzzleScript file that it's passing. And there's a lot because I've intentionally put a bunch in just to kind of see that it's working. Yeah, so basically I'm at the point where I've got the last two sections to pass, which are win conditions and levels. Yeah, well, so I've actually copied this from Rust's error reporting. So if I go back up to when I was actually getting errors from my Rust code, I mean, theirs is a lot fancier, but it's similar. It's like error, then there's a message, and then takes a little bit of effort to like understand what. In fact, I might have to expand that. Yeah, okay. I have to expand it to see what it's doing. Look at this. There's like an arrow. Is this an arrow? There is a method with a similar name. What does this blue line mean? It's like going ooh. Oh no, that actually makes sense because what it's trying to highlight parser and the method call. It's trying to be clever and like go, this thing is connected to this thing. And in trying to be clever, it's been slightly confusing. But like, here you go. This is like similar to what I've done. Expected list node, yeah, because Vec knew it was the wrong thing. And like a cool thing that Rust does, it kind of goes, are you sure you didn't mean this? Which is actually exactly what I meant. Except I didn't need to type all that. I could just type list node, but yeah. Anyway, so I modeled my error messages after the Rust ones. They're not as fancy, but to be honest, I think they're more readable. But then puzzle script's kind of a lot simpler, so yeah. Okay, so if I want to pass a keyword, I need to do parser pass one of keywords. And the way this works is you actually just give it a generic type parameter, which will be AST. Ooh, interesting. Yes, this is the problem I knew I was going to face. Well, I suppose the nice thing with Rust is that you can make it. So I've got my, like, you can do this with other languages as well. It's not a Rust specific thing, but I've got my editor set up so that it will report like warnings and stuff in line, which took me a while to get used to, but I actually quite like it. And it does offer, you can say just like accept replacement and it'll do it, which often is what you want. In fact, like right now, that is what I want. And that one disappeared for some reason. Okay, so I do have a slight problem here, which is at this time, so there are multiple formats that can be here. It's like this, no target on crate, some target, no target. So at this time, I'm at the beginning of a line. I mean, I'm not re-engineering. Wait, what? No, that was Sublime doing that. Sublime's Visual Studio is re-implementing Sublime. Sublime's already great. Who needs another text editor? But yeah, okay, so the issue I've got at the moment is that the first thing I need to pass is going to be either all, some, or no. But if it's all, then we can't have an on later. That's fine, I can just deal with that later. Okay, that's totally fine. So we're going to pass, what did I call them? I called them conditional... What did I call it? I don't remember. It's in here. No, it wasn't that at all. It's constrained selector, okay. In this case, I do want that. I don't want it there though, do I? Oh no, I do want it there, okay. I've got, oh yeah, okay, I need a, that's something I forget often. I often write it like the C++ way, which is like the name of the function and then the type parameters immediately after, but you have to do double colon. Yeah, mismatched types, that's true, but I'll sort that out afterwards. That is taking a mutable reference to diagnostics. So diagnostics is a vector of diagnostics, i.e. Like a dynamically sized array. And I want to pass it, like if you do this, when you pass to a function, you'll effectively pass a copy. Like the function, inside the function, if it tried to modify that thing, it would not be able to. Well, it would be able to, but it wouldn't end up modifying the one that's out here. And I want it to edify the one that's out here, so I have to pass a reference. If I just pass a reference, that's still not, it's not able to modify it. That just means it is seeing this diagnostics. But I want it to not only see that diagnostics, but it'll be able to modify it. So I'm going to send it a mutable reference. It's kind of C++ ish in that sense, in that by default, I mean, by default things will get moved, which took a long time for C++ to add that. That was added in like C++ 11, moving. So what will actually happen in this case is that will get moved into there, which will mean that actually, if I try and use diagnostics after there, it will give me an error saying diagnostics has been moved into this function. Unless vec implements copy, which it won't, but it probably does implement clone, in which case you can do that and do a clone instead. So I technically lied when I said that would do a copy. It will do a move. It'll do a copy if the thing supports being copied. Otherwise, if you just want to pass a reference, you got to say it's a reference. And if you want it to be a mutable reference, you got to say it's a mutable reference. And there's all sorts of things, there's all sorts of weird things in Rust that you have to get used to, like yeah, I guess is it a speed? I guess it is a speed thing. It's like having control over when you're actually like copying the memory from one place to another versus not, and just referencing the original. I quite like working in that frame of mind where you're thinking about this is a thing in memory, and copying it is like a thing I actively do. Like I guess in most like higher level languages, stuff is generally copied by reference anyway, like just by default, which can be fine, but it kind of leads to needing garbage collection, because if you can copy references around to a thing, then you can store those references whenever you like, and therefore you no longer know if, like, the lifetime of that object can exist beyond where it was created, and so therefore you need something kind of going, wait, is anything still holding on to this reference? Then you need to do reference counting, and then you go, nothing's holding on to this reference anymore, I'm gonna destroy that object. Yeah, and so simple things by value, big things by reference, and yeah, and that is effectively what you end up doing in like Rust or whatever. You'd often end up trying to only really copy like integers and floats and maybe small structs that can fit in some like a thingy. It's too late. Yeah, and I guess the thing is, so yeah, like, so similar to C++, this has like RAII in that if, so I'm creating this vector in this scope at the end of the scope, that will get destroyed. And so if I were to pass a reference elsewhere, it can't like hold on to that reference beyond the existence of this scope. And one of the nice things about Rust, so this is the big thing that Rust does, is it's like borrow checker and like lifetimes, is that it actually keeps track of like you've allocated this thing here, you've created this thing here, how long does it live for, and it will tell you like, oh, this thing you're trying to reference that was created in this other function won't actually exist anymore, and it will literally just stop you from doing it, which is different to C++ and C, where you can keep a reference, you can keep a pointer to something that has been deleted elsewhere, and you won't know about it until you get like undefined behavior, whereas Rust keeps track of that. But possibly the downside to that, probably the biggest downside to Rust, is that the fact that it keeps track of those things means it's very picky about when you pass references around and when you don't, and you sometimes are like, oh, I just want to pass this reference to this thing, and it's like, no, you can't do that because it might not exist at some point. You're like, no, but I know it exists. Yeah, so smart pointers in C++ do help with that, in that like, so you can, like in C++, you have like a unique pointer, which means like only one thing will ever own that thing, or you can have a shared pointer, which is basically a reference counted pointer, and will delete the thing only when the thing is holding a shared pointer anymore. So you can get it, but you don't quite get it to the same degree. Like Rust is really like, so one thing that's particularly annoying in Rust, which is especially annoying because, well, okay, so if you pass a shared reference, that's what this is, like a mutable reference to something, and then later call another thing also doing that. Oh no, that is fine. I can't even remember what the specific situation is. It's that they can't be at the same time. You can't have two mutable references to the same thing at the same time. If it can figure out that they won't exist at the same time, then it'll let you do it. But if they're at the same time, it won't let you do it. And that is to avoid... Is it only to avoid race conditions, or is there another thing it's trying to avoid? But it's trying to avoid race conditions, which is only relevant if you're doing like multi-threaded stuff. And I'm not doing multi-thread stuff. So sometimes there are things it's like, you can't do this because this could cause a race condition. I'm like, but I'm not doing multi-threading. So it doesn't matter to me. But someone could argue that like, oh, but you don't know, like in the future you might add multi-threading, or you know, your code might get used in a multi-threaded environment, and then you'll care. But I don't care. Rust borrow checker. Borrowing. Yeah, so basically you'd get this. Well, do they have a good example? First, any borrow must last, so borrow is like passing a reference to something. Any borrow must last for a scope no greater than that of the owner. That makes sense, because the owner, when the owner's gone, when the owning scope is gone, the thing gets deleted. So you don't want any references to last longer than that scope. Second, you may have one or the other of these two kinds of borrows, but not both at the same time. You can have one or more references, non-mutable references to a resource, or you can have exactly one mutable reference. And so yeah, the interesting thing there is if once you've got a mutable reference to a thing, you can no longer have an immutable reference to the thing. Again, because of like data races, yeah. but eventually you just sort of get used to it, and I like that's why I'm like finding it hard to even describe what the thing is. You just get used to it, and you're like, okay, I know I can't keep passing mutable references around to stuff, so I'll just like avoid doing it. Okay, so what do we have so far? We have. So I think in theory I could just like return. Do I want to do this? Okay, so what's the other thing that could happen there? I can do. Okay, so I need if. So if it fails to pass one of those keywords, so we want a pass expected. Pass expected, which is going to take a. So this is the syntax for a, like a lambda or a closure or whatever. And what does that takes a second argument, which is like not a valid. Yeah, this is not going to be a great error message for this, but sure. Win condition selector, sure. So then this will be if not parser expected, parse expected. I need to check how this even works. I've forgotten how my own code works. Else skip until next line. Is that right? When does that ever even return none? Then. So if it's not valid, you're right. Okay, so then we skip to the rest. Okay, that makes sense. Okay, so we do if let some so it's going to be selector equals that else. Which one was I just looking at that was really useful? This one. Yeah, let's copy that. It's going to be the same. I've definitely messed up on my indentation here. Can you fix it for me? There's missing a block after the condition. If let some blah blah blah. Oh, yeah, I didn't mean if let. Whoops. I mean let and then else. Yeah, whoops. Pass expected token is the name of the function. Because it's badly named. Mismatch types, expected pass selector, yes, because you are complaining about, well, you're first complaining about that. Mismatch types, get rid of that, whoops. Option keyword node. Huh? What have I messed up? Oh, well, that needs to be parser. Such that expected pass result found option where? Expected oh. Is the issue that it thinks I'm returning this, but I'm not returning this. Let's do this for now. Does that get rid of some stuff? No, it does not. Parser pass expected token. Expected struct pass results. Hello, Marcus. I'm coding far too late and struggling. Oh, okay, I'm missing a consume. Ooh, am I? No. Oh, the consume diagnostics in the wrong place. That's the issue. Yes, it needs to go there. Okay. Yay! Okay, that fixed that. Let's tidy up this a little bit. Thank you! And I hope you are gonna switch everything to Rust now. Actually, I don't hope that at all. What have I done here? Else, then no, that stays out here. So consume diagnostics come in. What have I done? How do I normally write this? Like that, and then consume diagnostics. Yep, there we go. Okay. Indeed. Okay. So now in theory, I think what we'd get if I ran this would be a bunch of errors about like target on crate being unexpected text. Nope, we don't get anything. Well, target is not a valid win condition selector. Oh. Okay, sure. Oh, that's interesting. Why does that happen? Why does that happen? All target on crate. I am skipping to the next line. Oh, because I'm returning none at the end. Yeah, okay. Yes, that makes sense. Okay, well that's fine. Okay, so that's the selector, and then we want to do a parse identifier, which is going to be similar. Is it going to be similar? Let's just copy it from elsewhere. Not there. We can copy it from sounds. Sounds has it. Somewhere. Object trigger. Object name. This. So we have object name. Parse identifier. Yeah. So if that fails to parse an identifier, oh, I also need to skip white space. Oh, not skip white space. Parse white space. Not self parser. Is that the right thing? Yes. Okay. Parse identifier, the object name. So right now, these will return none. And what will happen? I guess they'll also end up skipping. This feels wrong. This definitely feels wrong. Is it wrong? Kinda. It's kinda wrong. Okay, so if we got a selector, then we know that we have a win condition. But the problem is we don't know whether we have a that's an enum, isn't it? We don't know whether we have a constrained one or an unconstrained one. Well, only the constrained ones can take all of the keywords. So I guess I'll just assume it's constrained until it's not. Is that reasonable? This is wrong. So this is like this. And this takes this should be AST when condition node. This takes an AST constrained constrained condition node. Is that what it was called? Nope. Constrained when condition nodes. Of course. And it's missing fields. Correct. It's interesting that it's not asking me to add them. So we're going to have a isn't one of them missing? Oh yeah, it says I'm one of the fields. What was the other field called? It was called selector. So selector's the one we've got. But then the others we don't yet. Object ref non on non. And then the last one, constraint object ref. Definitely losing consciousness while I type this. Yep. Where was that again? That's in here. So this could be an option. That should still compile fine. Oh, this looks great. Am I putting self somewhere? Of course I am. It needs to be parser. Ta-da. Okay. I love that I now recognize that. It's like, if I get an error that's like this, it's like highlighting a billion things. First borrow, later used by call. Oh no, what does that mean? Well, it's just because I've written self instead of parser. I don't even have to think about it. Sure, there's a bunch of unused stuff here. That's fine. Well, I mean, I can do now. Well, in fact, can I not do? No, I have to do. Win condition dot selector equals dot object ref equals object name. Are you right about that? Win condition has no. Win condition. Is a win condition no constraint? Oh, I guess I have to. Oh. Ew. I guess I should just start with this. Okay. Okay. So if we fail to pass the object name, then we just return it as it is. Oh, I don't like this. Don't like what I'm doing here a whole lot. Do 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 ba 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 ba. I should probably stop. It's 11:30. Okay, it's half done, but we'll come back to it another day. Alrighty, folks. If Marcos is still around, goodbye, Marcos. Bye 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 bye. Good night.